Water heaters and compressors in dwelling units can operate with two phases and no neutral because they are connected in a split-phase configuration. In a split-phase system, the two phases have a 180-degree phase difference. This means that the current in one phase is flowing in the opposite direction as the current in the other phase. The split-phase configuration is created by using a center tap transformer. The center tap of the transformer is connected to the neutral conductor. The two phases are then connected to the two ends of the transformer. When a load is connected to a split-phase system, the current flows through the load from one phase to the neutral conductor. The current then flows back to the transformer through the other phase. In a dwelling unit, the water heater and compressor are typically connected to a split-phase system. The water heater is connected to one phase and the compressor is connected to the other phase. This allows the water heater and compressor to operate independently of each other. It is important to note that a split-phase system is not the same as a three-phase system. In a three-phase system, the three phases have a 120-degree phase difference. This means that the current in each phase is flowing in a different direction. Three-phase systems are typically used in commercial and industrial applications. Split-phase systems are typically used in residential applications. Let's delve deeper into the intricacies of split-phase power, focusing on its operation and applications, particularly in residential settings. The fundamental concept to grasp is that split-phase power provides two separate 120 volts lines derived from a single 240 volts source. This is achieved through a center tap transformer, a critical component in the system. The transformer's primary winding is connected to the incoming power supply, while the secondary winding is center tapped, meaning it has a connection in the middle. This center tap is grounded and serves as the neutral conductor. The two halves of the secondary winding each provide 120 volts with respect to the neutral. The key to understanding how this works lies in the phase relationship between the two 120 volts lines. They are 180 degrees out of phase with each other. This means that when the voltage on one line is at its positive peak, the voltage on the other line is at its negative peak. This phase difference is crucial for the operation of 240 volts appliances. Now, let's consider a typical residential application like a water heater. A water heater requires 240 volts to operate efficiently. In a split-phase system, the water heater is connected to both 120 volts lines. Because the lines are 180 degrees out of phase, the voltage difference between them is 240 volts. This allows the water heater to receive the necessary voltage for operation without requiring a separate transformer. The current flows from one phase through the heating element in the water heater and back through the other phase. The neutral wire is not used in this circuit because the load is balanced between the two phases. The same principle applies to other 240 volts appliances such as clothes dryers and electric ranges. These appliances are connected to both 120 volts lines and operate on the 240 volts potential difference. Now let's discuss the importance of the neutral wire in a split-phase system. While 240 volts appliances do not require a neutral wire, 120 volt circuits do. 120 volt circuits are used to power lights, outlets, and other small appliances. These circuits are connected to one of the 120 volts lines and the neutral wire. The neutral wire provides a return path for the current, allowing the circuit to function properly. The neutral wire is also important for safety. It provides a low resistance path for fault current to flow back to the source. This helps to trip circuit breakers or fuses, protecting people from electric shock. In a split-phase system, it is crucial that the loads and the two 120 volts lines are balanced. This means that the amount of current flowing on each line should be approximately the same. If the loads are unbalanced, the neutral wire will carry current. This can cause the neutral wire to overheat, potentially leading to a fire. To ensure balanced loads, it is important to distribute 120 volt circuits evenly between the two lines. For example, you might connect half of the lights and outlets in your house to one line and the other half to the other line. In summary, split-phase power is a common and efficient way to provide electricity to residential buildings. It uses a center tap transformer to create two 120 volts lines that are 180 degrees out of phase. This allows for the operation of both 120 volts and 240 volts appliances. The neutral wire is essential for 120 volt circuits and for safety. Balancing the loads on the two lines is crucial to prevent overheating of the neutral wire. To further elaborate, let's consider the practical implications of understanding split-phase power in a residential setting. Firstly, understanding the voltage levels available allows for proper appliance selection. Appliances are designed to operate at specific voltage levels, and using the wrong voltage can damage the appliance or create a safety hazard. Knowing that a split-phase system provides both 120 volts and 240 volts enables informed decisions when purchasing appliances. Secondly, knowledge of split-phase wiring is crucial for safe and effective electrical work. When wiring circuits or installing new appliances, it is essential to correctly identify the hot wires, neutral wire, and ground wire. Incorrect wiring can lead to electrical shocks, fires, or damage to equipment. A thorough understanding of split-phase wiring practices, including proper grounding techniques, is paramount for anyone working with residential electrical systems. Thirdly, understanding load balancing is essential for preventing electrical problems. As mentioned earlier, unbalanced loads can cause the neutral wire to overheat, potentially leading to a fire. By distributing 120 volt circuits evenly between the two lines, you can minimize the current flowing through the neutral wire and reduce the risk of overheating. Regularly checking the load on each line with an ammeter can help identify and correct imbalances. Fourthly, troubleshooting electrical problems in a split-phase system requires a solid understanding of its principles. When an electrical problem occurs, such as a tripped circuit breaker or a malfunctioning appliance, it is important to systematically diagnose the cause. This may involve checking voltage levels, testing for continuity, and inspecting wiring connections. Knowledge of split-phase power distribution and circuit behavior is essential for effective troubleshooting. Now let's compare split-phase power to three-phase power. As mentioned earlier, three-phase power is typically used in commercial and industrial applications, while split-phase power is used in residential applications. The key difference between the two systems lies in the number of phases and the phase relationship between them. In a three-phase system, there are three phases, each 120 degrees out of phase with the others. This provides a more consistent and efficient power delivery compared to split-phase power. Three-phase power is ideal for powering large motors and other high-power equipment. It also allows for smaller wire sizes and lower voltage drops compared to split-phase power. However, three-phase power is more complex and expensive to install than split-phase power. It requires specialized equipment and wiring, making it less suitable for residential applications. The choice between split-phase and three-phase power depends on the specific application and the power requirements. For residential applications, split-phase power is generally sufficient. For commercial and industrial applications, three-phase power is often preferred. In addition to the phase relationship, another important difference between split-phase and three-phase systems is the availability of different voltage levels. In a typical split-phase system, you have 120 volts and 240 volts available. In a three-phase system, you can have various voltage levels such as 208 volts, 277 volts, and 480 volts, depending on the configuration. These higher voltage levels are often required for industrial equipment. Let's delve deeper into the practical applications of split-phase power in the context of specific appliances. Consider a typical electric clothes dryer. These appliances usually require both 120 volts and 240 volts. The 240 volts is used to power the heating element, which generates the heat needed to dry the clothes. The 120 volts is used to power the motor that rotates the drum and the control circuitry. The dryer is connected to both 120 volts lines in the split-phase system as well as the neutral wire. The 240 volt circuit provides the power for the heating element, while the 120 volt circuit provides the power for the motor and controls. Another example is an electric range or oven. These appliances also require both 120 volts and 240 volts. The 240 volts is used to power the heating elements in the oven and stovetop, while the 120 volts is used to power the lights, timers, and other control components. The range is connected to both 120 volts lines in the split-phase system, as well as the neutral wire. The 240 volt circuit provides the power for the heating elements, while the 120 volt circuit provides the power for the lights and controls. It's important to note that even though these appliances require both 120 volts and 240 volts, they are still considered to be operating on a split-phase system. The 240 volts is simply derived from the two 120 volts lines in the system. Now let's discuss some common misconceptions about split-phase power. One common misconception is that split-phase power is the same as two-phase power. While both systems involve two phases, they are fundamentally different. In a split-phase system, the two phases are derived from a single source using a center-tap transformer. In a two-phase system, the two phases are generated independently, often using separate generators. Another misconception is that split-phase power is less efficient than three-phase power. While three-phase power is generally more efficient for high-power applications, split-phase power is perfectly adequate for residential use. The efficiency difference is often negligible in residential settings. A further misconception is that split-phase power is dangerous. Like any electrical system, split-phase power can be dangerous if not installed and maintained properly. However, with proper grounding, wiring, and safety precautions, split-phase power is a safe and reliable way to provide electricity to residential buildings. To further clarify the role of the neutral wire, it's essential to understand its function in both 120 volts and 240 volt circuits. In a 120 volt circuit, the neutral wire provides a return path for the current. The current flows from the hot wire through the load and back to the neutral wire. Without the neutral wire, the circuit would not be complete and the appliance would not function. In a 240 volt circuit, the neutral wire is not typically used. The current flows from one hot wire through the load and back to the other hot wire. The voltage difference between the two hot wires is 240 volts, providing the necessary power for the appliance. However, even in a 240 volt circuit, the neutral wire may be present for safety reasons. If a fault occurs in the appliance, such as a short circuit, the neutral wire can provide a low resistance path for the fault current to flow back to the source, tripping the circuit breaker and preventing a dangerous electrical shock. It's also important to understand the different types of wiring used in split-phase systems. The most common type of wiring is non-metallic sheath cable, also known as Romex. This type of cable contains insulated hot wires, a neutral wire, and a ground wire, all encased in a plastic jacket. Another type of wiring is conduit, which is a metal or plastic pipe that protects the wires. Conduit is often used in commercial and industrial applications, but it can also be used in residential settings. When working with electrical wiring, it's essential to follow all applicable codes and regulations. The National Electrical Code, or NEC, provides detailed guidelines for safe and effective electrical installations. It's also important to use the correct tools and equipment for the job. This includes wire strippers, pliers, screwdrivers, and a voltage tester. A voltage tester is essential for verifying that circuits are de-energized before working on them. Now, let's discuss some common electrical problems that can occur in split-phase systems. One common problem is a trip circuit breaker. Circuit breakers are designed to protect circuits from overloads and short circuits. When a circuit breaker trips, it means that the current flowing through the circuit has exceeded its rated capacity. This can be caused by too many appliances being plugged into the circuit, a short circuit in an appliance, or a ground fault. Another common problem is a loose connection. Loose connections can cause arcing, overheating, and even fires. It's important to regularly inspect wiring connections and tighten any loose connections. A further common problem is a ground fault. A ground fault occurs when current flows from a hot wire to ground. This can be caused by damaged insulation, faulty wiring, or water damage. Ground faults can be dangerous and should be repaired immediately. To prevent electrical problems, it's important to follow these safety tips. Firstly, avoid overloading circuits. Do not plug too many appliances into a single circuit. Secondly, use surge protectors. Surge protectors can protect your appliances from voltage spikes caused by lightning or power surges. Thirdly, inspect wiring regularly. Check for loose connections, damaged insulation, and other signs of wear and tear. Fourthly, hire a qualified electrician for any electrical work. Do not attempt to do electrical work yourself unless you are properly trained and licensed. Electrical work can be dangerous, and it's always best to leave it to the professionals. Let's reiterate the core concepts of split-phase power to solidify understanding. Split-phase power utilizes a center-tap transformer to deliver two 120 volts lines that are 180 degrees out of phase. This configuration enables the operation of both 120 volts and 240 volts appliances within a residential setting. The neutral wire plays a crucial role in 120 volts circuits, providing a return path for current and ensuring safety by facilitating fault current flow. Load balancing is essential to prevent overheating of the neutral wire. Understanding the principles of split-phase power is crucial for appliance selection, safe electrical work, troubleshooting, and preventing electrical problems. Remember to always prioritize safety when working with electricity and consult with a qualified electrician for any complex or potentially hazardous tasks. These safety precautions are vital in protecting the electrical systems and devices in the dwelling. With a solid grasp of these concepts, individuals can confidently navigate the intricacies of residential electrical systems and ensure safe and efficient operation of the various appliances and devices.